After having the good concepts of odd numbers, even numbers, prime numbers, composite numbers, factors and multiples, we can solve easily these kinds of simple statements. We need to where we have to state whether they are true or false. Sometimes you may get this in exams. So let me try to explore this. All right. First one is here. The sum of the three odd numbers is even. So how we can be sure whether it's true or false? So for that, you just take an example. Let's take an example. Let's add three odd numbers. Okay, it's three odd numbers. Simple we are doing here. Suppose 3 and then 5 and 7. So 3 plus 5, how much is that? 3 plus 5 is 8 and 8 plus 7 is 15. So I'm going to get 15. And now what is this 15? 15 is going to end with 5 and 5 is a odd digit. So it means this whole is an odd number. Right? Let's take one more example. Suppose 21, 35 and 39. If you add this all, how much we're going to get? Let's add here 21, 25 and 39. How much we'll be getting? 5 plus 1 6 and 6 plus 9 15. Care about 1. 2 plus 1, that's 3, plus 2, that is 5, and 5 plus 3, that is 8. Again we're going to get 85. So 85, again it's going to end with 5. So that's why this is an odd number, right? You can take similar more examples, but you need to do this all things quickly. So just take a simple example and see whether that's going to be true or not. So they're saying that will be even numbers, but 2 times we got odd numbers. It means that's wrong. That's false. This is a false statement. This is false statement. All right. So the sum of the three odd numbers is actually odd number, not even. Now let's do about the second one. The second one is the sum of the two odd numbers and one even number is even. Let's check it out. Sum of the two odd numbers, that time already we discussed that is even number, right? In previous video only we have done that. And even number and even number, if you add that will be even. So that's true, but I'm gonna do it. Alright, so sum of the two odd numbers, I'm taking just very simple two odd numbers like 3 and 9. Okay, 3 and 9. In sum of two odd numbers we have to add one even number. So let me add any simple even number, that's 2. Okay, so 3 plus 9, that is my 12, and 12 plus 2, that's gonna be 14, and 14 is even number. Already I had said that we'll be getting an even number, and yes, we got it here, even numbers. So 4, that the last digit is 4, so that's why this is an even number, and that's 100% true. That's true. All right. And if you want to know in the previous one method, like already we had learned that the sum of the two odd number is always even number, and this will be even number and then plus one even number, and again sum of the two even number is always even number, that we had learned in the last video. So that's true. Now let's go for the C, the third one. Third one is like the product of the three odd numbers is odd. Let's try. 3, 5, 7. 3 times 5 times 7. So 3 times 5, 15, and 15 times 7, you'll be getting, I think, 105. So see, 105 here. 105 is ending with 5, digit 5. So what is this 5? 5 is an odd digit. So this is an odd number. And we're getting right, so that's true. Right, one more example we need to take. Not we should not get confirmed in only one. I'm taking like suppose 9, 3, let me say 1. So 9 times 3, that is 27, times 1, again 27. So 7 is again the odd digit, that's why the whole 27 is an odd number, and again the statement is right, that's true. Right, if an even number is divided by 2, the quotient is always odd. If an even number is going to divide by 2, the quotient will be always odd number. How we can be sure? Let's try. Okay, let's try. Suppose, let me take an even number. Suppose 24. I'm going to divide this 24 by 2. So 2 times 1, that is 2, and I got nothing. And again I'm going to drop this 4, and 2 times 2, that is 4. I'm going to subtract it. I'm going to get nothing here, remainder. So what's my quotient? Quotient is 1, 2. The quotient is always odd number, but I'm getting here even number. Okay, I'm sorry dude, I need to say you are incorrect, you are false. alright, because I'm getting here even number. Next one, all prime numbers are odd. What about the 2? We already said the 2 is an even number, and this is the smallest prime number. Only the 2 is the exception. Only 2 is a unique prime number which is even and is a prime number. So 2 is only the case where we are getting even number also and the prime number, and this is the smallest prime number also, right? Sorry dude, again I need to say you are the false.